The second example is going to be the same idea where, again, I'm going to give you the function and we're going to ask the skeleton questions and then we're going to use our chart to help us graph, all right? So it says graph by hand the polynomial function f of x equals negative 2x to the fourth plus 3x cubed. What is the end behavior of the graph using the leading term test? So remember, your leading term's not necessarily the front term, it's just the highest power. In today's notes, they both happen to be the front term, right? So this is an even degree, and it's opening down because a is negative, right? So think of your parabola. What's an even degree do? It goes in both directions, but if it opens down, they're both going down. So if you need to kind of sketch what it's going to look like, we'll have this arrow down. We're not too sure what happens in the middle, and then this other arrow going down. Not necessarily, but yeah, if they have a fourth degree, you could come back up, do tangent, and come back down. Those are usually the multiplicities, though, of the zeros. All right, so the zeros. How do we go about finding the zeros? Remember, the zeros are just making your function equal to 0. So we'll have 0 equals negative 2x to the fourth plus 3x cubed. Again, I'm going to always give you something that's either already factored or you can factor it. So what can we take out of negative 2x to the fourth plus 3x cubed? X cubed. X cubed. And I'm going to take out a negative just so, if your leading term's negative, I usually factor it out. Just makes things a little bit easier. So this is 0 equals negative x cubed. I didn't touch the 2, but negative 2 divided by negative 1 is a positive 2. X to the fourth, take away 3, leaves you with an x. Is that okay? Positive 3 divided by a negative 1 is a negative 3, but I took away its x cubed. Does that look right for the zeros, or the factoring part of the zeros, I guess? So what we're going to do is we're going to just take each of those terms, guys, and set them equal to 0. So set negative x to the third equal to 0, and set 2x minus 3 equal to 0. Well, on that first one is divide both sides by negative, you get x cubed equals 0, right? Take the cube root of both sides, you get x equals 0, okay? So this right here, even though there's math we could do, we don't really need to do it. Anytime you have x squared or x to the fifth equaling 0, that just means x equals 0. Here what we would do is do what? Add 3 and then do what? Divide by 2. So x equals a positive 3/2. So those are our two zeros. They each have a multiplicity of 1, which means we're going to cross through the x-axis at 0 and 3/2. We're going to cross through. The question is, are we going to be coming up or down or whatever it may be? So notice my box I give you is perfectly for these, okay? On the test, I'm going to give you a generic one, so you might not use all the columns. And I don't do that to confuse you. It's just easier to not have to make a new box each problem. All right, so what we're going to do is we're going to start at negative infinity and we're going to stop at our first 0. What are we going to stop at? 0, okay, because that becomes before 3/2. So we do negative infinity to 0. Start where you left off, 0, and go to your next 0, 3/2. And then what's our next interval? To infinity. Perfect. Keep in mind what 3/2 is. So if you put 3 divided by 2 in your calculator, that's 1.5. So kind of keep that in mind. All right, so our first 0 is 0. What is a convenient test value to pick? Negative 1. Is everybody okay in agreement? You can pick negative 1,000,000, negative 12, but negative 1's a nice, smaller, easy number to deal with. Going over here, what's a nice test value between 0 and 3/2? 1. You could do 1/2, but I'd always kind of avoid fractions if possible, so we'll just do 1. And then over here, what's the easiest term probably out of 3/2 to infinity? You can do 4, but I would do 2. 3/2 is 1.5, so stay smaller and closer to it, so that's 2. You're not wrong if you pick 4, though. And that's what's going to be hard about me grading. You all might pick different test values that are in those intervals. So I'll pay attention to all of it. Okay, so how do we find your function value? Again, really this should be f of x. Just plug your test value into your original function, and just be careful, make sure you have parentheses around it. So when we plug negative 1 in here, when you raise it to the fourth power, it stays positive. Times negative 2 would be a negative 2. And then when you plug in negative 1 here, it stays negative. So I got negative 5 when I did that. Did anybody else get negative 5? I did. Okay. So what does that mean? It means when we're leading up to crossing out the x-axis at 0, our sign is negative, which means we're below the x-axis. When you plug 1 in, I got a positive 1. Does that sound right?
Yeah, that's right.
So that means we're going to cross through at 0. We're going to go up into the upper y values to a positive 1, which means we're above the x-axis. And then 2, we already kind of know what's going to happen since we know what our end behavior looks like. If we started from the negative infinities with an even, we're going to go back down to the negative infinities. So with 2, I got an y value of negative 8. Does that look right? So that's negative, so that's below the x-axis. All right. Here, this next step number 4, finding our y-intercept, is not the most helpful because the whole idea of the y-intercept is you make x equals 0. But if you notice on this one of our zeros was 0. So it ends up being the same thing. We go through the origin, so it doesn't really help us. But let's just show that we do it. So this means make x equals 0. So we have f of 0 equals negative 2 times 0 to the 4th plus 3 times 0 cubed. But when you multiply anything by 0, it's going to be 0. It's just 0. So our y-intercept is one of our zeros. So that's not going to help us a whole lot. All right. So what I'm going to look at here is, I have a pretty good idea what's going on here. I'm kind of curious about what's happening here because I know I'm in the positives, but it's like 1 the highest I go. So I actually, my additional point I'm going to do is 1/2 like Gavin had mentioned. So I am going to find f of 1/2 just because when I cross over that x-axis and I'm up in the positives, is 1 the highest I go? Do I go slightly higher? I don't know. So I'm just going to plug 1/2 into my function. And I'll just tell you real quickly, guys, that's just 1/4, 0.25. So that gives us an idea that when we go and cross up to that 1, 1, that's probably going to be our high point. We just barely, we're on our way up, all right? So it's going to be kind of hard to know, so I'll let you flip it, and I'm going to leave mine here, and then I'll catch up with you, okay? We are gonna graph these points, right? So this is 0, 0, and this is 3/2 0, okay? So make sure you graph 0, 0, and then 3/2 0 on your sheet. So go ahead and flip it over, guys, onto page 4. We're gonna graph 0, 0. So go ahead and graph the origin, and then 3/2 0 is 1.5 0. So graphs are two x-intercepts, and they're very close to each other, okay? Then here are our 3 test points. So go ahead and graph -1, -5, -1, -5, 1, 1, and then 2, -8. And the only other point we really have to graph, guys, is this point down here, 1/2, 1/4. So you go over 1/2 and then barely go up. Okay, so and what it ends up being kind of like a W. So when you go up and cross through 0 and you hit through that 1/2, you kind of curve weird. I'll show you what I'm talking about. So let me catch up with you guys. All right, so we had 0, 0. 1/2 0, 1, 1, -1, -5, 1, 2, 3, 4, 5, 2, -8, and then 1/2, 1/4. So he's like barely here, okay? And then we know the ends are both going down, right? So what we do when you come here, you kind of curve in like this, like make a weird W shape, okay? So you kind of make a weird W shape because you have to hit all those points. And that's what's going to typically happen. Anything bigger than x squared that's even usually is more W-like than a parabola, okay? There we did it. We graphed that crazy guy without a calculator, but let's just double check. So in my y equals, I'm going to clear out my y equals, and I'm going to type, make sure you use the negative button, not the minus button, -2x to the 4th plus 3x to the third. And there he is. So notice he looks like our guy where it has that little weird smidge, that W going on there. All right, so there's one more concept, which is, at first you read it and you're like, what are they saying? And then I'll try to explain it in words. It's easier to explain it than how you read the definition. So objective 2, the intermediate value theorem is actually one that's pretty important if you guys are going on to calculus. I know some of you said you might be going to brief cal. This is something that you see there. So intermediate means middle, okay? So this just basically means the middle value theorem. So it says for any polynomial p of x that has real coefficients, where one x is a and one x is b, but they're not equal to each other, then if the two y values, so that's what p of a means, or the p of b, the two y values, if they're opposite signs, meaning one sign is positive, one sign is negative, you've crossed the x-axis. And therefore you have a 0 between a and b, okay? So just think of this as if you have two values where this is x1 and x2, and y1 and y2 are opposite signs, then we're going to have a 0 between x1 and x2. AKA, guys, we cross the x-axis. So if you have two x values, one's positive, one's negative, you had to cross the x-axis at some point to get to the other guy, to get to the other side, right? Cross the, so it's like a chicken. Why did the polynomial cross the x-axis to get to the other side kind of idea? So what they're going to do is in your homework, in your My Math Lab, they're going to give you a function. They're going to give you two values, a and b, but those are just x values. All they want you to do is plug in a, figure out what its y value is, particularly just the sign. Plug in b, figure out what its y value is, specifically just the sign. And if the signs are opposite, that just means you cross the x-axis at some point. So that means there is a 0 between -4 and -1. Okay? If they're the same sign, so if they're both positive, they're both negative, it doesn't mean you didn't cross it, it just means you're not too sure. Maybe you stayed up the whole time, or maybe you crossed and came back up and you're already back to where you started, all right? So this only tells you if they're opposite, you for sure crossed. But if they're the same, you may or may not have crossed, all right? So let's just do this problem. So for part A, we're just going to find f of -4 first. So that's -4 to the third plus -4 squared minus 8 times -4. And again, we don't necessarily even care what the value is. We care about the sign of the value, okay? But you really can't figure out the sign of the value unless you just plug it in and figure out what the value is. So if you trust me, you just put this in your calculator, beeper, bopper, beep, all right? And you get a y value of -16. So let's just make note of the sign that it's negative, okay? So at -4, this function is below the x-axis. So when we go to plug in -1, if it's a positive value, that means we cross the x-axis at some point, okay? So let's see what happens. Let's find out what f of -1 is. And again, you just put it in your function, you do the computation, beeper, bopper, beep. And you get a y value of 8. And what is its sign? Positive. So it means if you were going to plot this on the graph, you would plot -4, -16. You would plot -1, 8. And if you were going to connect those dots, do you cross the x-axis at some point? Yes. So since these have opposite signs, there is a 0. Do we know what it is? No, we just know it's some value between -4 and -1. We're not sure where it crosses, but yes, there is a 0. So since they have opposite signs, it means to go from -16 to +8, I had to cross the x-axis at some point, okay? Do we know what the 0 is? No, but we know the 0 is somewhere between -4 and -1. Guys, part B is the exact same idea, okay? This one I got a 0 again. I might have you guys double check it because I don't know if I trust myself. I kind of question giving you two of the same ones. So how do we know if there's a 0? We're going to find f of 1. So 1 cubed plus 1 squared minus 8 times 1, is that just negative 6? Kind of quick math. 1 plus 1 minus 8 is going to be negative 6. So f of 1 is just negative 6. And again, I'm going to make note that it's negative. So again, if I was graphing this function, I would graph the point 1, negative 6. So I know I'm below the x-axis. The question is, when I move horizontally to an x value of 3, am I still in the negatives? If so, I don't know if I crossed the x-axis. But if I have a positive value, then I know I've crossed over. So let's figure out what f of 3 is. 3 cubed plus 3 squared minus 8 times 3. Yeah, I get a positive again. I get positive 12. Is that the right mental math? 3 cubed is 27, plus 3 squared is 9. So 27 plus 9 is, what's that, 36. 36 minus 24 is 12. Okay? Again, do I really care that it's 12? No, I just care that its sign is positive. So what does that mean from 1 to 3? I started below the x-axis, I went up above, so there is a 0. I crossed the x-axis at some point. So yes, there is a 0. So they end up being identical. I kind of wish I would have given you one that both the signs were negative, and so you'd say there may or may not be a 0. Okay? If they're negative, I know I'm sitting below the x-axis at some point, but I don't know what's happening in between. I may have gone up and came back down, or may have never crossed at all.